Hello, my name is Alex Dorsey, and this is Lab 3 Black Hole. The purpose of this lab is first to find the mass of a simulated black hole given the mass of an orbiting star and using the interactions that it has with the black hole. And then we use a glow script computational model to solve for the mass. The second part of this lab involves determining the initial velocity needed for a spaceship to launch off of a nearby planet. And the spaceship has to be able to approach the black hole and escape the black hole planet system without falling into the black hole. So the first key concept is Newton's second law, and using the momentum principle we can derive the velocity update formula and the position update formula, which we've done in previous labs before. Another key concept is parallel and perpendicular forces. So we can break up the net force into the parallel direction of motion and then the perpendicular direction of motion. So for the parallel, that is in the p hat axis, and it points towards the direction of motion, and it indicates whether or not your system is speeding up or slowing down. And then the perpendicular component of the force is in the n hat axis, and it points towards the center of the kissing circle or the direction of motion, like perpendicular to the direction of motion, and it basically indicates the change in direction. Lastly, another key concept is the universal law of gravitation, and we can use the gravitational force to solve for the mass of the black hole. So for the first computational model, we have our initial conditions, where we're given the star's mass, we're given g, we're given delta t, and we basically just set up the initial conditions like so. And then when we go through the iterative process, we have to update the velocity and the position of the star, and then using the universal gravitational constant. So for part 1, we found the mass of the black hole to be around 8.07416 times 10 to the 33 kilograms. And this is just taken as the average of the experimental masses of the black hole. And in this model, the system was the star and the surroundings was the black hole and space. Some possible sources of error include rounding errors after each iteration and using a rounded value for g. So the star follows an elliptical orbit around the black hole, and it has parallel and perpendicular components. So in the parallel component, we can see that the star speeds up as it approaches the black hole and slows down as it leaves. And then in the perpendicular component, it is always pointing inwards towards the center of the ellipse. And this is because it's breaking up the net force, which is just the force of gravity of the black hole on the star. And so the difference between the net force and the rate of change of momentum, so while they're mathematically the same, one is describing the sum of the forces acting on an object, while the other simply describes changes in the object's velocity and motion. So it's kind of just two different ways of looking at the same value. So then for part 2, we have to basically find the initial velocity of a spaceship through trial and error. So basically you set up your initial conditions and then you iteratively set up the different forces that are acting in the system. So you have the force of the black hole on the planet, you have the force of the ship on the planet, you have the force of the black hole on the ship, and then you have the force of the planet on the ship. And once you are able to calculate all of those forces, you add them up to create your net forces. And then using these net forces, you're able to create a model where you just plug in different values for the initial velocity to see which one allows the spaceship to basically just graze the black hole. So for part 2, the initial velocity that I got was negative 3.85 times 10 to the 7 in the x direction and 1.28 times 10 to the 6 in the y direction. And as you can see, that made it so that the spaceship was able to just pass by the black hole without getting sucked in. So then for part 2, the discussion question, basically you needed to increase the y component of the initial velocity and decrease the x component of the initial velocity in order to get the spaceship to orbit the black hole as opposed to just pass by it. And so then this orbit basically describes the spaceship constantly falling into the black hole.